Assalamu alaikum, dear students. We are discussing exercise 2.1, and the question 5 of this is we have to find the value, or we have to solve this expression tan inverse root of 1 plus x square minus 1 upon x. Here you know that if we have to substitute in this expression root a square plus x square, always put x equals to a tan theta. Here we have 1 plus x square, so a is here 1, so this means that here we will put 1x equals to tan theta, because a tan theta, a is 1, that is x equals to tan theta, or theta equals to tan inverse x, which implies that the given expression, which is tan inverse root 1 plus x square minus 1 upon x, is tan inverse root of 1 plus tan square theta minus 1 upon tan theta. Now here 1 plus tan square is simply sec square. So root of sec square is simply sec theta minus 1 upon tan theta. That is tan inverse sec theta minus 1 upon tan theta. Now convert this sec and this tan into sine and cos. So we get tan inverse of sec is here 1 by cos minus 1 upon this tan is sine theta upon cos theta. So which is simply, after simplification by cross multiplication and by cancellation, it is 1 minus cos theta upon sine theta. 1 minus cos theta upon sine theta. In terms of half angle, this 1 minus cos theta is twice cos square, twice sine square theta upon 2, and 1 plus cos theta is twice cos square theta upon 2, and sine 2 theta is twice sine theta cos theta. So here this given expression, that is tan inverse root 1 plus x square minus 1 upon x, becomes, here in place of 1 minus cos square, it is simply twice sine square theta by 2, because 1 plus 1 minus cos theta is twice sine square theta upon 2. Here we have full angle in the sine theta, so we can write this as twice sine theta, sine 2 theta upon 2, because 2 cancels, we will get this sine theta. So using here sine 2 theta, which is sine 2 theta by 2, is twice cos theta by 2 sine theta by 2. Sine and sine cancels, 2 and 2 cancels, so it is simply tan inverse of tan theta by 2. Now tan cancels by this composition or by inverse, it is simply theta by 2. Here theta is tan inverse x, which implies that it is tan inverse by 2. So this means that tan inverse of root 1 plus x square minus 1 upon x is tan inverse x by tan inverse x upon 2. Similarly, you can find solve this tan inverse root 1 minus cos x upon 1 plus cos x. Here you simply use 1 minus cos x is this 1 minus cos x is twice sine square theta by 2, and 1 plus cos x is twice cos square x by 2, that is 2 cancels, square root cancels, it is simply tan theta in this angle, that is tan theta by 2. So this is the required way to solve this expression, or to find the value of this expression, that is tan inverse root 1 minus cos x upon 1 plus cos x. Now another problem is we have to find this value, or to solve tan inverse 1 upon root x square minus 1, root of x square minus 1. Always put, if you have root x square minus a square, put x equals to a cos theta, or x equals to x equals to a cos theta. Here we have a equals to 1, so this means that here we put x equals to cosec theta, which implies that theta equals to cosec inverse x. So it is tan inverse 1 upon root cosec square minus 1, which is simply cot square root. Now square and root cancels, it is 1 upon cot theta. Now reciprocal of cot is tan theta, that is tan inverse tan theta, which is simply by this composition, tan inverse of tan is simply theta, that is tan inverse 1 upon root x square minus 1 is, here tan is cosec inverse x, that is cosec inverse x. Also you know that cosec inverse x plus sec inverse x is pi by 2, that is cosec is pi by 2 minus sec inverse x. Either this tan inverse 1 upon root x square minus 1 is cosec x, or its value is pi minus 2 pi by 2 minus sec inverse x. Now another problem is we have to find tan inverse cos x minus sin x upon cos x plus sin x. Here this angle or the angle of this tan inverse is simply cos x minus sin x upon cos x plus sin x. Whenever you have expression of this type, that is expression has numerator and denominator containing cos and sin, always divide by cos, always divide this by cos. So dividing upon by cos in the numerator and denominator of this angle, so we get here tan inverse of, it is cos minus sin upon cos divided by cos x plus sin x upon cos, that is 1 minus sin x upon cos upon 1 plus sin x upon cos, which is simply tan inverse of 1 minus tan x upon 1 plus tan x. Now here the value in terms of tan of here the value of 1, or in terms of tan its value equals to tan pi by 4, that is we can write 1 as tan pi by 4. Here in denominator we have 1 plus tan x, or here tan x can be written as 1 into tan x, that is this one can be written as tan pi by 4 tan x. So this tan inverse 1 minus tan x upon 1 plus tan x is tan inverse tan pi by 4 is this one. Tan x is its original tan x 1 as it is plus 1 tan x, that is tan x tan pi by 4. So this becomes tan a minus tan b upon 1 plus tan a tan b, that simply equals to tan a minus b. Here a is pi by 4, that is pi by 4 minus x. So tan cancels, it is pi by 4 minus x. Hence the value of this tan inverse cos x minus sin x upon cos x plus sin x is pi by 4 minus x. Another problem is tan inverse x upon root a square minus x square. So here we have a square minus x square. Put x equals to a sin theta or x equals to a cos theta. Here we will put x equals to a sin theta, which implies that theta equals to x by a or theta equals to sin inverse x by a. So tan inverse x upon substitution becomes tan inverse x is a sin theta root a square minus a square sin square theta, because x is a sin theta. Now a square in the root became simply a root of 1 minus x square. This expression becomes cos theta. Now a cancels, sin upon cos is tan theta, that is theta equals to sin inverse x by a. You know that sin inverse x by a plus cos inverse x by a is pi by 2, or sin inverse x by a is simply pi by 2 minus cos inverse x by a. Hence the value of this expression is simply sin inverse x by a or pi by 2 minus cos inverse x by a, because by using the property that sin inverse x plus cos inverse x is pi by 2. Now we have to find this, or to solve this expression, tan inverse 3ax minus x cube upon a cube minus 3ax square. You know that the value of tan 3 theta is simply 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. So this means that here if we put x equals to tan theta, it simply becomes tan 3 theta, tan 3 theta. So tan and tan inverse cancels, so you simply get here 3 theta, that is theta equals to tan inverse x by a. So the value of this is simply by putting x equals to a tan theta. So in this way you can solve these problems. So inshallah in tomorrow's lecture we will discuss few more problems of this exercise. So thank you.